Hi students, today we are going to discuss about the number systems in our first chapter of class 9. Okay, so you have already learned about the number system in your previous classes, like about natural numbers, whole numbers, integers, all these things. Okay, I just give you briefly today about those number systems, and we will discuss later on about more details about rational and irrational numbers. So first thing is the natural number. You know it about natural number. And what do you know about natural number? And what is the other name of natural number? We can call these numbers as counting numbers also. Why it is called counting number? Because those numbers are used for counting purposes, like 1, 2, 3, 4, 5, like that way. It's go on and on and on up to infinity. Okay, there is no any maximum natural number or maximum counting numbers. So early human beings are use those numbers for counting purposes, and it is start from 1, and there is no any maximum number. So those numbers are basically used for counting purposes. That is why it is called counting number as well as the natural number. So next we know about the whole numbers. That means if we include 0 with the natural number, it becomes the whole numbers. So whole numbers means actually nothing but the collection of natural numbers along with the 0. That means 0, 1, 2, 3, 4, 5, like that way, go on and on and on up to infinity. So that series is called the whole numbers. Okay, to represent some big values like 1000, 10,000, 1 lakhs or anything, we have to add some zeros along with the other natural numbers. So that is why the importance of 0 is most valuable. Who invented the 0? Indian scientist Aryabhatta invented the 0. So that is the series of whole number as you know it. So next one is called integer. So integer, okay, integers. So let us see. You see, if you let us take, suppose you want to pay somebody some amount of money from your balance. So what will happen? It will decrease your balance or diminish your balance, or subtract your balance, okay, money. But if you receive something, some money from other party, then it will add your balances. Okay, so to represent those payment and receive, we need some sign here, so like a minus sign or plus sign. Okay, by default if we don't use any sign, then it is called a plus sign. That means 4 rupees means how much? Actually I have received 4 rupees, that means plus. And minus 30 means 30 rupees means actually I have to pay somebody 30 rupees, debit credit. So that is why you need some other sign apart from positive to represent a number. In case of temperature below the 0 degree centigrade, we say that that value should be like minus 4 degree centigrade or 3 degree centigrade, anything, any value with a minus sign here. And for the upper value, it is always positive value, that means 4 degrees Celsius. If it is positive, we don't mention the sign here. You know about all these things. That is why in that series we need another family that is called the integer. So in case of integer, apart from the whole numbers, we have to add minus values as well as. like 4 minus 3 minus 2 minus 1 0 plus 1 plus 2 3 4, like that way. In both direction we can move up to infinity. There is no any maximum value, there is no any minimum value in case of integers. So negative values are also included here. So that family is called the integer, as you know it. So next come to the next number system, that is called the rational number. Okay, rational numbers. What is rational numbers? Those numbers which can be expressed in the form of P upon Q, where P and Q are integers. And the second condition should be Q is not equal to 0. So here in case of rational number, it can be represented in the form of P upon Q, where two conditions that should be satisfied. One is that P and Q, both of them should be integers value, and the denominator Q should not be equal to 0. So if we see, all the integers are said to be the rational number. Why? Because you see, suppose 1 is a whole number, or you can say integer or a natural number. 1 can be represented or expressed in the form of P upon Q. That means 1 by 1. That 1 equal to 1 by 1. That means P equal to 1, Q equal to 1. So it is a rational number. Or you can take any value, minus 4 suppose by 1. It is also minus 4 can also be represented in the form of P upon Q. So it is also a rational number. In this way, all the integers are rational numbers. Only condition should be there, the denominator should not be equal to 0. If we take suppose 1 by 2, that should be equal to, you can say 4 upon 8. That means same, that is equal. Or we can say 20 by 40, or 200 by 400. All these fractions are remain same. That means equal to each other, and we will represent all of them on behalf of all of them in the number line. We will represent it as 1 by 2. Okay, it is called a equivalent rational number. Equivalent rational number. Okay, so rational number, in case of rational number, actually it derives from the word ratio. You know about ratio. So ratio means P by Q format. Okay, so basically that is why it is called the rational number. And another series is there which is just opposite to the rational number, and it is called a irrational number. Irrational number. So in case of irrational number, those numbers which cannot be represented in the form of P upon Q are called the irrational numbers. For example, square root 2, pi, all these numbers are called the irrational numbers. So those are the just basic definition of number system. We have to discuss a lot more about other things about rational numbers and irrational numbers later on. But right now I just briefly to tell you about all these things. Okay, so if we now collect all the rational numbers and irrational numbers, and finally it becomes a real numbers. So real numbers means actually what? Combination of rational numbers and irrational numbers is called the real numbers. So later on we will discuss more about irrational and rational numbers. Now in our second part we are going to discuss about all this number system by a graphical representation. Okay, let us erase these things, and you can see again by pausing the video. Okay, so next one is that let us take 5 numbers. One is 5. Next, suppose 8 divided by 2. Next, 10 upon 3 square root 2 and 0. Here I have written 5 numbers, and we have to identify that numbers which is belongs to what category. Okay, let us draw a circle to represent the number system. The first one is the small circle that is called the n. That means that circle contains all the natural numbers. Okay, so if we draw another circle to represent whole numbers, it seems to be like that. So whole number is a little bit big circle than the natural number. That means all the natural numbers are all the natural numbers belongs to whole numbers apart from some other numbers. That means 0. So whole numbers means actually natural number plus 0. Again, if we draw another circle to represent integers, it seems to be like that. Again, integer actually collection of all the whole numbers, and in addition to that, some other values also there, like negative values. So again, if we draw another circle, okay, so it seems to be like that. So that circle is called a rational number, Rn. Okay, so those are the circles represent the number series. We have another circle which is called which one is left? The irrational number. That is the IR, irrational number. Okay, that circle is separated from all these circles. So if we collect rational numbers and irrational numbers as a whole, it becomes the real numbers. Real numbers. Okay, now we have to examine the numbers, which one is belongs to which circle. So let us take the first number 5. 5 is a very simple number. That means 5 is a natural number. If it is natural number, definitely it will be a whole number and integer and rational number. Okay, so 5 is simply a natural number. Now, in our second example, minus 8 by 2 means actually minus 4, isn't it? So minus 4 means what? Actually minus 4 means it is not a natural number because minus sign is there. It is not also a whole number. It is an integer. So minus 8 by 2 is an integer. Okay, so here it is. Now 10 by 3 means how much? If you divide 10 by 3, it becomes 3.3333. It will go on and on and on. That is called the non-terminating decimal values. If we find out the decimal expansion of that number, it seems to be like that. Okay, so one digit is repeating itself every time. Okay, that is why it is called a rational number. Why it is called rational number? Because it is in the form of P upon Q. That means P means 10, Q means 3. And another definition is also there, that if we find out the decimal expansion of that rational number, we will get either it is a terminating value or non-terminating repeating values. Okay, so that is the rational number. Now in case of root 2, square root 2, what is the value of square root 2? It becomes actually 1.4142135 ... It's go on and on and on. Okay, that is also the decimal values, isn't it? The decimal expansion of square root 2 seems to be like that. So if it is a rational number, why it is not a rational number? We know that square root is not a rational number, it is an irrational number. So why it is irrational, why it is rational? So rational because it is non-terminating repeating values. Here it is non-terminating but non-repeating also. There is no any digit which is repeating itself every time. So that is why that value is called the irrational. So that is another definition of irrational values. Okay, in case of decimal expansion. We'll discuss more about decimal expansion in our later classes. Today, for right now, for this class, we have just I have just brief you about irrational numbers. Okay, later on we'll discuss more about it. And finally, in our last number, that is 0. So 0 belongs to which category, which circle? It is actually a whole number, isn't it? It is not a natural number. It is a whole number, or we can say it is an integer or rational number also. 0 is also a rational number because 0 can be expressed in the form of 0 by 1, 0 by 3, anything. So 0 is also a rational number as like as whole number. Okay, but we put it here in case of whole number. So from this graphical representation, I think you better understand what is the difference between rational number and irrational number particularly. So we have to move our next segment, that is we will discuss about the some basic things about rational numbers. To learn about these things, let us take 3 examples. One is called 7 by 8. That is a rational number since it is in the form of P upon Q, isn't it? So next one is suppose 10 by 3, and the third one is 1 by 7, and here it is square root 2. Okay, so in case of 7, 8, let us see, we have to divide 7 by 8. So it is not divisible because 7 is less than 8. So we have to give here 1 0 here. So here it is a point. So 8 times means 64. How many remainder? I mean 6. Again 60, it becomes 60. Here it is 7. 856, isn't it? 7 times means. Here it is 4 0. Now it is 5. So finally the remainder becomes 0. So when the remainder becomes 0, we say that it is terminating after a certain steps. Okay, so it becomes 8 7 5. That is the value, quotient value. Now let us divide 10 by 3. So here it is 10 3. How much? I mean 3. Here it is 3. 3 times means 9. 1 is remaining. Since 1 is less than 3, not divisible by 3, we have to put where 0, that is point here. So again 9. Again 1 is remaining. Every time it becomes 1. So here it is 3. Again 9. That means 3. Again 1 is remaining. Again 0. Again 9. Again 1. It becomes like that way. Okay, it will not stop here. It is a non-terminating value. So repeating also, that means 3 is repeating every time. Finally we can say 3.3333, or in a short form we can write here 3.3 bar. Bar means 1 digit is repeating every time. Okay, that is the value. Now in our third example, let us take, we have to divide 1 by 7. It is not divisible since 1 is less than 7. Here it is 0, so point is here. Here it is 1, 7 is there, 3. Remaining is 3, remainder is 3. So 30. Again 7 4 times means how much? 28. 2 is remaining, 20. 7 2 means how much? 14. Okay, that means 6 is remaining. That means 60. 7 7 ja how much? So sorry, 7 8 ja how much? 56. So 56 means how much? 40, isn't it? 4, remainder is 4. Again 40. 7 5 ja 35. Here it is 5 is here 50. So 7 7 ja how much? 49. So ultimately 1 is remainder. If it is become 10, that means again 7, again it comes to 1. Okay, 1 4 2 like that. Again it is a non-terminating value, decimal value, but repeating 6. How many digits are there? 1 2 3 4 5 6. 6 digits. After 6 digits it is repeating. Okay, so that can be written as like that way. So 0.14285711428 like that way, or we can say 0.14285 bar. It is repeating. So from these 3 examples we can conclude that in case of rational numbers we have either it is a terminating value, terminating after a certain stage or steps, or it may be non-terminating like that way, that or that. Those 2 examples are non-terminating repeating values. It is a terminating values or non-terminating repeating numbers. Okay, rational numbers are either terminating or non-terminating repeating numbers like that. Those, okay, either one digit may be repeated, or either one digit may repeat, or more than one digit may repeat. So it will depend upon the value of the rational numbers. So what are the irrational numbers then? Irrational numbers are those which are non-terminating and non-repeating also. Non-repeating. Two conditions should be satisfied. One is non-terminating, another is non-repeating. Then only it becomes irrational numbers. For example, square root 2. It is 1.4142135 like that. It go on and on and on. So in here you see there is no any digit is repeating itself in a pattern. So that is why it is called the irrational number. Okay. So till now, whatever I said about rational and irrational numbers, that is only in a theoretical, concept. So practically, if we going forward solve some problems, then we will better understand all these things. Okay, later on I will show you how to solve some rational and irrational numbers problem, how they operate, and what are the values of their properties actually.